Hello everyone. Welcome to this series of quantum computing, do it yourself. Albert Einstein once said that if you can't explain it simply, you don't understand it well enough. Having looked at a lot of materials which are available on the internet on quantum computing, they tend to confuse me rather than making it clear for me. So I wanted to create a series which can help you understand quantum computing, benefits of quantum computing, and then use quantum computing for any of your use cases. So in this series, we will understand the terms used in quantum circuits, then hands-on using Python as the default language. We'll use Python to create qubits, gates, operations, moments, and circuits using circ library, CIRQ. Then we will see TensorFlow Quantum for ML, and then real-time use cases using quantum computing. So let's get started. A quick introduction for me. I am Naresh Jasotani, and I'm a specialist customer engineer working at Google. I have over 16 years of experience, and I have also published a book, Adapting TensorFlow for the Real-World AI. So let's get started. Think about TensorFlow. There are processors for TensorFlow like TPUs, tensor processing units available. But then with lots of data and different types of use cases, there are barriers which can be eliminated by quantum computing. The top 4 use cases where quantum computing is being used today are cryptography, medicines, materials, machine learning, and big data. So farming, healthcare, and other use cases like smart cities and combating global warming are the use cases of quantum computing. But for this course, we will focus on machine learning use cases. So as part of this course, what we will do is we'll understand what is quantum computing, circuits. We will create a qubit and different components of a circuit using circ in Python. So just follow the series and you will come to know how, where, and when to use the quantum computing. So let's get started. In the previous video, I explained this quantum computing already. So if you want to see my previous video, the link is given in the description section of this video. So click on the link in the description section. So what is a quantum circuit? As explained, the quantum circuit is a model of quantum computation. You create a quantum circuit so that a quantum model, a quantum computation can happen. The qubit, which is a bit equivalent of classical computing, is generated or created for quantum processing. You have multiple qubits, you have n qubits. Then you have gates. The gates are those items which can perform a calculation on an operation on a qubit. So gates are logical gates which perform computations on qubits. In this diagram, you see K0s, K1, K2, and K3 are different types of gates known as quantum gates. We'll discuss about gates as well. Then you have operations which you can perform on adjacent qubits like this one. You can perform operations on K3 here on Q1, Q2, but you cannot, you can have operations lined together in this form in the time axis. And then a moment is described as a single time slice. So if you slice the time, this is a moment. So in order to create a circuit for the quantum computations, what you would need, number 1, qubits, number 2, gates, number 3, moments, and number 4, the circuit when it is created will run the circuit. I know it can be a little confusing to start with, just coming in from the classical computation world, but stay with me. My suggestion would be just follow the exercises in the next few videos and you will get a little comfortable there. Please don't forget to watch the previous video where I've explained the quantum gates in detail, quantum circuit in detail as well. So, quantum defining qubit. Again, assuming you are good in Python. If not, I'm also going to put a Python link in the video description section below so that you can do some basics of Python. So, Circ has three main methods of defining qubits. You can see that I have a Python notebook which is available in the Google Drive link in the video description section below. You can use this Python library, Python notebook to access the code. There are three main methods of defining qubits. The first one is circ.named qubit. You can label a qubit and define a qubit. Second method is circ.line qubit. And the third method is circ.grid qubit. Understand the reason why we are defining qubits. The qubits are the first building blocks of a quantum circuit. Once we have defined qubits, we will then use gates for doing some operations on top of qubits. Then these gates would go into moments and then our entire circuit will be formed. So the first step to create a circuit is to define set of qubits. To do those qubit defining, there are three methods: named qubit, line qubit, and grid qubit. Please note that the circ is a Python library which can help do all this. Let's look at the Python code. So if you look at here, this shows the named qubit, wherein circ the library dot named qubit a. Q underscore a is now the qubit. Same is the case here. Q underscore b is the qubit. So Q underscore a equals a and Q underscore b equals the type. I just use type of. I'll show you how this is achieved in the hands-on. Next is you define the line qubits. The line qubits is defined as circ dot line qubit, and number 3 is how many what line qubits you are defining. Let's see here. So Q underscore C is a line qubit with the value 3, and then you are defining a line qubit in range. So rather than defining a qubit one by one, using the line qubit, you will define a dot in range. That means you're defining three qubits, Q10, QL1, and QL2. That means there are 3 qubits, and QL0 has the value 0, QL1 is 1, and QL2 is 2. And then finally, I have the grid qubits. The grid qubits is in the form of a square. It can be 00 to 033 when you say square 4. If you say square 5, it will be 00 to 44. So let's take a look. So there is a grid qubit which I have defined over here with 4 and 5, and I have defined another qubit, Q underscore 16s. Please note that QA, QB, QL0, L1 and L2, and QS16s, all these Qs are arbitrary variables. You can have it anything. So these are the 3 different methods of defining a qubit. Let's go to the code and let's look at how you define these qubits. Right. You can access the notebook Quantum DIY1 creating qubits in the using the Google Drive link in the video description section below. Once you open this, what you're going to do is go to File and say save a copy in the drive. Make a copy. Once you have made a copy in the drive, then you will start running this notebook. The first statement, pip install quiet circ, is going to install circ. Please note that the first time you have to install it. Then you import circ. The first method which we are going to see is using the named qubit. So q underscore a circ dot named qubit a, q underscore b circ dot named qubit b, as seen in our theory section. Print q underscore a and print type of q underscore a. Similarly, print q underscore b and type of q underscore b. And it shows q underscore a is a and type of q underscore a is the named qubit. Let's look at the line qubit. So this is a detailed line qubit. You can create a line qubit one by one, or you can create using in range. Q underscore C is circ dot line qubit 3, and line qubits in range are QL0, QL1, QL2, and QL in 3 range. So 0, 1, 2. And I printed the type and the value of these qubits. Running this will give you the details on these qubits. Next is the grid qubit. In the grid qubit, I defined Q4 underscore 5 and we are using grid qubit 45. Here you have Q16 square. That means it's going to form a square qubit grid of 16. So if you say 4, that means 0, 1, 2, 3, and that will be 16 in number. The length of the qubit, the number of qubits would be 16. And how do you see that? Is using Q and type here. So running this, you would see this. Now, in the next section, you will have hands-on, and I highly recommend you to do hands-on so that you understand how all of these come together. So in the next, we will talk about how do you access qubits.